Extra exercise. ABCD is a parm. I is the midpoint of AB, and E is the point defined by IE equal 1 over 3 ID. So you join I with D, and you measure the length of ID, and take 1 over 3rd of it, and accordingly you plot IE. Okay, so this is E. By choosing the system B, so B is the origin 0, 0, BC, so this is I, BA, so this is J. Find the coordinates of the points A, B, C, D, E, I, and E, then show that A, E, and C are collinear. Now, in the system B, BC, BA, B is the origin, so it's 0, 0. Of course, C is here, so here we have 1, 0. At A, we have 0, 1. At D, we have 1, 1. You can see this clearly because BD is equal to 1 BC plus 1 BA. So the X component is 1 and the Y component is 1. Now, I is the midpoint of BA. So I is at the middle of BA, therefore BI is half. So this means that the coordinates of point I are 0, half. Or you can say BI is equal to half BA. This means it's equal to 0 BC plus half BA. So the coordinates of I are 0, half. Or without justification, you can write it directly. Now we want to find the coordinates of E. Now, to find the coordinates of E, there are two ways. One way is to write BE as a linear combination of BC and BA. So since B is the origin, we want to write BE as a linear combination of BC and BA. Now, to do this, we have BE is what? BE is BI plus IE. Now, why did we think of inserting letter I? Because we don't know anything about E except that IE is equal to 1 over 3 ID. So that's why I is given with E. So I inserted letter I. Okay, so I want to write BE as a combination of the other vectors. So I inserted letter I here. I got BI plus IE. Now, what do we know about BI from the figure? Okay, so here is the figure. BI is half BA. So I replaced here BI by half BA. And we know that IE is 1 over 3 ID from the given. Now, we have half BA plus 1 over 3 ID. But what's ID? Look at the figure. ID, I can replace it by IA plus AD. Why am I doing this? Because I want to write ID in terms of the other vectors, BC and BA. Okay, so when I write ID as IA plus AD, IA is simply half BA, so we're done. And AB is equal to BC, so I can replace AD by BC, because AD is equal to BC. Okay, so this is what I did here. So it's 1 over 3 IA plus AD, but IA is half BA, and AD is equal to BC. Expand now, you get half BA plus 1 over 6 BA plus 1 over 3 BC, which is 2 over 3 BA. When you add these two, you get 2 over 3 BA plus 1 over 3 BC. So we were able to write BE as a number times BA plus a number times BC. These numbers are the coordinates of point E. Now, the second way is, we are given that IE is equal to 1 over 3 ID. This means that XE minus XI is equal to 1 over 3 into XD minus XI, and YE minus YI is equal to 1 over 3 into YD minus YI. We substitute the coordinates of the points that we know, which are I and D, to get the coordinates of E. Okay, it's very simple. Now we want to show that the 3 points A, E, and C are collinear. Now to do this, notice from the figure they are collinear. To do this, we can look at vector AE and at vector AC, for example, and show that they are collinear vectors. So I found knowing the coordinates, I found the components of each vector. Okay, AE is 1 over 3 minus 1 over 3, and AC is 1 minus 1. So you do, as usual, XE minus XA, YE minus YA, you get these. XC minus XA, YE minus YA, you get 1 minus 1. Then we apply, as usual, XY prime minus YX prime, and show that it's equal to 0. So we get X times this, 1 over 3 times minus 1 minus 1 over 3 times this. And when we calculate, we get 0. This means that the vectors AE and AC are collinear vectors, and since they have point A in common, then the 3 points A, E, and C are collinear. Now, I want to say a remark about showing collinearity without coordinates. Notice in the previous chapters, in chapters 8 and 9, we used to show that 3 points are collinear by showing that the vectors are collinear without using coordinates, by writing one vector as a multiple of the other, of course as a non-zero multiple of the other. So in some questions in exams, for example, sometimes they give you in the same problem two parts. One part should be solved without coordinates and another one should be solved with coordinates. That's why I'm saying this remark. So in order to show that A, E, and C are collinear points without using coordinates, we want to write AE as a multiple of AC or AC as a multiple of AE. Now let's look at the figure. AC here is a diagonal, so we know that AC is equal to AB plus AD. Now I want to write AE as a multiple of AC. To do this, I will try to write AE as a linear combination of AB and AD also. Since AC is AB plus AD, I will try to write AE in terms of AB and AD. How do we do this? First, I know information about IE. So I know IE in terms of ID. So I want to write AE first as AI plus IE, okay? Because I know information about IE. So this is AI plus IE. Now AI, I can replace it by half AB, okay? So I can replace AI by half AB. I remain with IE. Now what should I do with IE? I know I use the given. IE is 1 over 3 ID. So I will replace IE by 1 over 3 ID. Okay, so now we have 1 over 3 ID. But what do we know about ID? I can decompose ID as the sum of two vectors. Which two vectors should I choose? I should choose two vectors that would give me something related to AB and AD. Because remember, the first thing we said is that AC is AB plus AD. So my goal is to decompose everything in IE in such a way to write it in terms of AB and AD. So we reached ID here. ID, I will write it as IA plus AD. Now, what's IA in terms of AB? Notice IA is half BA, so it is minus half AB. So I will replace IA by minus half AB, and AD will remain as it is. So let's see the answer. So as we explained there, I said AC is AB plus AD. AE, I introduced here letter I because I know information about IE, so it became AI plus IE. We know that AI is half AB because I is the midpoint, and IE is 1 over 3 ID from the given. We inserted here letter A, so we got here IA plus AD, and also, I replaced IA by minus half AB from the midpoint property, and then you expand this, you get minus 1 over 6 AB plus 1 over 3 AD, and simplify, you get 1 over 3 AB plus 1 over 3 AD, which is what we want. We got the same coefficient here. If you take 1 over 3 as a common factor, you will get AB plus AD. But what's AB plus AD? AB plus AD is AC. So we were able to write AE as a linear combination. Sorry, this is AC. We were able to write AE as a linear, as a multiple of AC. Okay, so AE is 1 over 3 AC. This means that vectors AC and AE are collinear, and since they share the common point A between them, then the points AC and E are collinear.